Hello, this is Alex from cables.gl. I want to talk to you about the brand new workflow that is in the last update of Cables that allows us to use textures instead of arrays to manipulate our mesh instancer and point cloud and rotation and stuff like that, but with the texture. And it took me a little bit to understand like what, how does this even like what am I doing here? But it's actually really simple now that I've used it for a few days. And I'm just going to cover the basics and then maybe get you experimenting with what's possible. And I think you're going to really enjoy using this new workflow and definitely comment on it and see how it is for you, because I think we're really excited to keep pushing this forward and then get like really, really crazy with this in the future, because it is way faster than using arrays. And for a lot of us, it's a lot easier to look just at a texture and at a glance, like understand what's happening in it, compared to looking at this huge list of XYZ values in an array, for example. So what we have here is, it's an okay example, but we're gonna just go through it real quick, right? So I have a geometry that I take from a GLTF scene, and then this gets converted with one of our new operators called geometry to texture. And then we end up with a square texture with kind of like this crazy mess of pixels. And each one of these pixels is a location for a point, right? So if this geometry to texture is 210 by 210 pixels wide and high, then that's however many instances we'll have. And all of these colors, the blue, red, and green, tell the XYZ positions of this point cloud, and then the points are populated, all right, and so then an interesting thing happens here. I put this texture into an image compose. And I think that's really cool, because you start to be able to use the image compose, which is traditionally like for us to do 2D post-processing, or maybe creating like normal maps or doing some sort of, visual effects. But here we're doing the same things, but now they are data effects. So now we can use a draw image multiply, for example, to multiply a position of a vertex, or we're doing kind of additive colors to then add to a position of a texture or a vertex. So I think it's very, very crazy to start to think of these blend modes in a new way, and then all of the different texture effects to see which work really well with this new workflow, and just get really into it, because I had no idea this would be possible, where I'm just almost recreating like the area effects that we have, which are super easy to use as well. But now I'm like visually able to understand, okay, this is a green kind of waveform moving up and down, and that's going to move my pixels up, on the y direction. And then here it's just some color that I put into the point material. And basically, yeah, that's a really funky new way of working with point clouds and mesh instances and things like that. So let's maybe look at other things that I did here. Here I kind of reconstructed a plane of cubes that then are ordered in such a way that I can use a wave gradient from the bottom left scrolling to the top right, or here it's spinning in place. And this creates kind of an interesting wave of cube instances. And yeah, it's hard for me to continue to explain it, but like you can get really into like diffusion effects or fading mesh locations or whatever. Like it's really wild, and I don't know. I think I'm just all over the place, because I just keep thinking of what else I should show you. So this is a super easy, simple example that maybe we'll take a look at soon. And then in this example, we're using another operator called texture to coordinate grid, which is Another great way to start with this entire workflow, because it's quite visually understandable how it's going to take a texture, for example, this text mesh, and then just create this grid with, you see it has a little bit of color here, red and some almost invisible greens, but then this can be quickly plugged into a point cloud, and then you will be able to manipulate your um, texture in kind of like 3D space now, because it's now a point cloud. So it's kind of handy, nice intro, I think, to this whole world, because you don't have to really worry about where is this pixel, and is it going from the bottom left to the top right, and all those things. But you'll get into it, I'm sure. But I think this particular operator is really great, a really great start. But we'll go through it as well. And then here, I just wanted to see if I can take this texture to coordinate grid operator and then plug it into not a point cloud, but into a mesh instancer. And in the end, I kind of ended up with some sort of 3D font here, which is kind of cool. And if I plug in this, I can also start doing crazy effects that are super, super quick on a GPU. I can't even imagine what this would cost me if I used CPU arrays and things like that. So pretty incredible. I'm not going to show you these two just yet because they're super weird and experimental. But let's start from the beginning. So let's say I just want a cloud of points, right? I'm going to put down a point material because we're going to be working with a point cloud from texture. So it needs a point material. And then I'm going to put in this point cloud from texture. Now, let's take a look at this operator. It looks pretty simple. And let's actually compare it to, oh, there it was, point cloud array. Kind of similar. It has some shared settings like number of points to limit the amount of points you have. This new one has axis, so you can actually flatten your point cloud if you want to work in 2D or kind of like a 2D plane. And then this one has some texture coordinate stuff, but we don't really miss anything because we also can do the same thing in the point material where we have a scramble texture coordinates. Where is it? Colorize, randomize. So it's kind of the same as this bit here. But you see that this one takes only arrays and this one takes textures. So here we have coordinates. So that will be an array of XYZ. And here's a texture input. And that's going to be an HDR RGB texture. I'm going to tell you all about this. So we're going to create an image compose. And I'm going to throw down a pixel noise. I like this operator. It's kind of nice and tidy. So how is this texture? How should it be constructed? Definitely try to keep it square. It's that's just a lot easier to work with, I think, in the beginning. So then we have a 64 by 64 texture, and you'd want to use HDR toggle on here, because then we can push and pull the values of these colors, maybe outside of our visible range, but it's still going to have the data in the texture that will allow us to put this point cloud in specific areas in our project. Because if we don't use HDR, then we're really limited to the values of the colors, and then you won't get the control that you would want when you're using these new operators of mesh instance and point cloud creator from texture. So what we're going to do is we're going to connect this into our input for the texture, for the position texture. And we see that it doesn't look great. All of our points are kind of flying into the top right here. I'm going to put down a viz texture. And let's get into it. Why is this happening? Because white and black are kind of like all the colors in one, right? So it's RGB if you put those colors together in additive mode, right? When you add them together, not mix them like with paint or something like that. When you add them together, you get white. So what that means is the red channel is our X. So that's moving a pixel, for example, left to right. I'm going to use this kind of analogy, right? And then Y will be green, and that's up and down. And then Z will be blue, and that's forward and back. So what's happening is we're using the color white. Let me put down an orbit control here. We're using the color white, or this value white, and which is red, green, blue, and it's just shooting off into space here. What we need to do is to use kind of distinct colors. So let's switch it to RGB, and now we have this 3D point cloud. So we're almost there, right? And if I turn on HDR, you're going to run into some times where your texture is not actually in HDR. So for example, this pixel noise at the moment is not in HDR mode. But if I want to offset this, I can put down this thing called RGB Math. And it becomes really useful with this workflow because now I can use one of these operations. So for example, I will subtract X, which is one of these values here, from my color, which is C, right? So C minus X. And to center this whole thing, I'm going to just subtract 0.5. And now when I rotate my point cloud, it's pretty much centered, right? I think it's exactly centered, actually. And what else can we do now? Now that we have sort of a grasp of us having a 64 by 64 pixel texture, which means 64 times 64 instances for this point cloud. And then we have some values. And our pixel noise is actually set to 10. So although we maybe are generating 64 times 64 instances, we don't really see them because we're giving pixel values with these colors, or the pixel color values are telling the point cloud where to place these instances, and it's not a high enough resolution here. So we can actually type in 64 and 64, and now our texture is getting like a per pixel random color from this pixel noise operator. So now we have a lot more visible instances because each pixel is a different color, more or less, and we have this big cloud. All right, so moving along, what else can we do in this image compose that is pretty cool and super quick and like, you know, it's just wild what we can do. We can use this brightness to make the mesh or the point cloud of our noise here bigger or smaller. So you might get into moments, for example, here where I converted, or maybe it was this one, where I converted a GLTF scene node, which is this face, with this geometry to texture operator. And I can immediately see that I'm going to have some issues here because this is super bright. So that means this geometry is giant, right? Like the scale of it is huge because these values are even visually telling me that they're super bright. So it might not fit, and I might fight like to find it sometimes. So here I use the brightness to contrast to lower the values of these locations for the vertices, and now I was able to kind of place it into the project how I want it. You know, and I didn't use a transform operator here. I didn't change anything in my cameras. I'm just using this texture to manipulate where to place this point. So without it, I would think, oh, something's broken. There's like this weird pixel in the center. You know, I broke something. But actually, the reason why I don't see anything is because all those points are super far away, and they might not even be drawn in my like camera view, like the frustum or whatever is too small. But yeah, so keep that in mind. Like if you visually see like, whoa, those are really bright, just lower the brightness a bit, and then you can manipulate kind of the size of your point cloud. Um, so what else can we do here? Well, we can play around with this operator in particular where we're manipulating the Z, and maybe we can put a timer on here, maybe slow down a bit. And then if I loop this, then we start to kind of have some sort of flying particle effects. So pretty interesting, but I don't know. It's all right, but it's still the point is it's incredibly fast to do this at the texture level as opposed to using an array to do the same thing. So right now we're barely even using any resources because all we're doing is manipulating this simple texture. What else? Let's try this other operator I talked about. I'm just gonna remove everything and redo it. And let's save and reload actually because of us. I'm not gonna talk about it. So we have this thing, right? We're gonna put down a sequence to space out our stuff. And I'm gonna type in, what was it called again? Brain error, texture to coordinate grid, right? Texture to coordinate grid. So what we need to give this operator is pretty much just a normal 2D texture. So what I'm gonna do is, I'm gonna use a render to texture because I wanna show you something really trippy. So if I put a circle in here, I now have a circle drawn on this texture. I'm gonna make it square just to make my life easier. 128 by 128, and turn on auto aspect. And then I'm gonna plug it into this texture coordinate grid. And now you see that this operator creates kind of something similar to the geometry to texture. This one kind of takes a texture to a grid. And then this grid is now our locations for points. So if I put down point cloud from texture and give it a point material, we should be able to just see this circle on our screen. Nice. So this is another thing that you can manipulate with an image compose, of course. I just can't get over this. So drop it in here and then connect it to our texture input. And then again, see, we have some issues because first of all, I'm not really keeping my textures the same size, but I think it's a lot easier if you do. You don't get into some kind of filter modes, blurring your pixels or something like that. And then another issue here, this texture to coordinate grid, like the geometry to texture, it creates an HDR texture. So actually, let's check that. Texture info. HDR true, right? And our image compose is not in HDR. So we're not able to grab all those negative values, for example, or maybe just things outside of the non-HDR range of values for the colors. So it still works. So if you want to really attempt to maybe keep your project super light for mobile devices, or you're doing like just a lot of point clouds that are animated and things like that at the same time, and you don't want to use HDR textures, as long as you kind of keep them in this 0 to 1 area, or I guess it's an area. It's like a spawn area for your point cloud, right? Does that make sense? So anyway, you just have this cage that's a lot smaller in dimension where you can paint those locations for the vertices. So if you're able to use a tiny texture for that and keep those colors non-HDR, definitely do that. Definitely experiment with that, because I think you shouldn't ignore the ability to do that. Like you're not just stuck to HDR, but in this case, let's just turn on HDR and stop rambling about that. So what I can do is, again, put in the brightness and just make it bigger. And of course, since we're in HDR mode, I can just put in a number and then go outside of those legal 0 to 1 values. And now I'm able to even go into like crazy land, right? And all this stuff, actually, we can see this texture here. It's kind of really nice looking. So is texture pretty wild. So we can see that these ones are green, so they're probably above. Red are mostly to the right. Yellow is kind of a mix of green and red. Yeah, so you start to kind of understand what those colors mean, and see if as I lower them, those colors get less bright, and our point cloud gets smaller. All right, so that's cool. And what else can I show you? Let's return to one of these pre-made projects I have here. So Mesh Instrancer from Texture also has, unlike the point cloud, here it just has a size. It has rotation texture, scale texture, and a color texture to colorize your mesh instances. And the rotation is also RGB because you're rotating on the X, on the Y, and the Z. So if in this example, I'm rotating on the Y from here, and I change it to black, you see that the meshes are no longer rotating. And if I add a red, now they're rotating on the X, and that's how it looks. Because we have a gradient waveform that goes from the bottom to the top, and our array of cubes rotates as the color gets brighter and darker, right? So if I want to rotate them on 2 axes, then I just add another one and maybe add a green and maybe add the frequency a bit, and also hook up a timer to the offset. So now it's going a bit crazy, but if I lower this, then it's a bit more visible that we're rotating not only on the X, but also on the Y. So yeah, keep in mind that the rotation texture is also RGB. Now, the scale is also RGB, but since I want to keep them all even, the scale on the X and the Y and the Z even, I just use black and white, right? Because I'm now scaling all those axes at the same time. So I get this even scaling of my cubes. What else? And I guess I'll just cover, like, how did I make this field of cubes? I basically just use a wave gradient to tell the mesh instancer to paint, hey, the first one in this corner will be red. Let me just turn off this waveform here. Waveform, gradient add. And then I'll unplug the rotation and the scale. So this one will get the most red in our texture. So that will be the most the rightmost cube. And then as it goes right in this texture, then the value on the x-axis gets smaller and smaller. So then it goes into negative values, and then it's not visible really, because how do you do a negative? So we get this line of cubes, and then as it goes up further in this texture, it'll go from left to right and then up, then these also start to get this green color as well. So then they're also moving on the Y direction. So that way we're painting a texture that tells the mesh instance or point cloud where to put these instances and points with colors. So we're not converting anything. We're just like straight up painting these colors, and mixing them with additive mode. We're doing this all by hand, which is, if you're gonna do something crazy like paint this by hand, definitely comment below or show it to me, because that's awesome. I still didn't reach the level where I can look at an object and go like, oh, I understand the vertex texture for this thing. I'm going to paint it now. But I think if we all keep using this, maybe we'll get to that point. Maybe. Yeah, I guess we're pretty much done. Definitely ask if I didn't cover something. This is kind of a lengthy tutorial and a bit rambly, but I also want to show you this experiment here where I took kind of an old and forgotten vertex position from texture operator and used it with the new operators we have in store now, which will push and pull the vertices of this rectangle, which is basically 4 vertices, right? Let's do geometry info. It's just 4 vertices. So for 4 vertices, I need a 2x2 texture. And then I'm going to color each one of these pixels a specific way. And then here I put an RGB Math to offset them in the right place. And I end up with my rectangle again, which is kind of cool. And yeah, here I'm just adding stuff just to see what happens. So see the colors are changing and the values start to manipulate where this plane is being drawn, which is kind of cool. And after that, I was thinking, well, can I kind of recreate basically our vertex displacement operator with image compose and this vertex position from texture? And I think I was relatively successful in doing it. And basically, yeah, I have a much higher resolution version of this, basically. So this texture is 128 by 128. And then I'm just putting in a random effect like a plasma just to see what happens. And it actually looks quite great, like good. And I was actually surprised by this. But I think that could be also another future for this workflow where we're going to get into meshes from vertex textures. But anyway, hope you enjoyed this. Definitely comment below. Maybe this is not the greatest format. Also let me know. But please try this new workflow and tell me how it goes. Thank you. Bye.